This is about showing you a process that is quite possibly the only way we can hope to bring large-scale manufacturing of carbon fibre bicycles back to Europe. We are excellent at making carbon fibre. Think about all the Formula One cars, all the Le Mans cars, all those aerospace and military contracts that you see, and nearly every single team on the F1 grid is based here in the UK, making fantastic carbon fibre products. We know how to make really good carbon fibre. What we can't do is make it en masse at scale because it is a very labour intensive process. In this video, we're going to show you a way that 3T have developed a process of reducing the amount of parts required, reducing the amount of finishing time, and trying to automate as much of that as possible. It's fascinating. I think it's a glimpse of the future. I hope you enjoy this video. The biggest difference between what 3T and Time do is that 3T filament wind, and there's so much here that we can't show you. But essentially with this B-roll that we are allowed to film, you can see this arm going backwards and forwards. But as they change the speed of the rotation and the speed that arm moves, you're completely changing how those fibres are layered up. I'd like you to meet Enrique, the engineer here. Enrique, welcome. Could you try and explain how 3T do things differently?
Well, I think in a way there's some similarities, right? Because we work with dry fiber. So our technology allows us to have hollow preforms, hollow tubes that you can place later on in the mold, while Time, they base on their wax core in which they lay those braided tubes. So the way we create those preforms before they get into the mold.
So they're now not only doing one frame at a time in terms of doing down tube, seat tube, top tube, they're now doing like 5 top tubes all in one go. So constantly refining that engineering process.
So this is actually the down tube of the Race Max 2, okay? And the main innovation in our case is not the winding itself. This is a really well-known technique in the composite industry. The reason why we have gotten 2 patents, it is because what we are able to obtain after that process, which is a complex shapes, right? This is not a round tube, this is an Aero shape.
Yep.
Which is dry fiber, and it's stable enough that it can be held and manipulated, okay? So the good thing also about this technology is that we don't need a core where to lay on top, because the tube itself, they are already stable enough to be manipulated.
So this is fascinating. So one of the things that we have only can show you a little bit of, here's the B-roll, is there's a process that goes over all that white powder that you saw gets set through a very special 3T magic.
Yeah.
And so this has got some structure to it. It's very fragile.
It's delicate.
But you've taken out the solid core that was used for that, and then now it's got this wrap around it. But somehow we need to get this into a mold and solid enough. So can you just talk, how does this now come together, Enrique?
So this is what we call the kit, okay?
Yep.
We do a sort of a pre-assembly before going into the mold. And then in here, in these boxes, we have the rest of the components we need to finalize the frame.
This is braided carbon that we'll recognize from Time manufacturing.
In this case, this is the chainstay, okay? This is hollow, so we preform it around a core. That later on we remove, so we use this sort of spray that gives the stability to it.
And this one we can still see there's that foam core there, and that stays.
That stays.
That's that. So the life of your frame, that's going to be in there all the time. Yeah. The variety of different construction methods here is blowing my mind a little bit. So in all of these trays here, there are various methods of adding support to the internal structure before it goes into the mold. These little bits of closed cell foam, these are so light. This is one that actually stays in the frame. It never ever gets removed. There's another section here with another type of foam that we've actually just been seeing being cut here on a big sort of CAD cutter, which is fascinating. And the blue stuff that we cannot show you because that's really, really secret stuff. But that's all to go on the inside to make sure that those bags are inflated and you get a really perfectly smooth internal surface. Some really clever tech. I wish I could show you more of it, but this is just a little glimpse. I'm sure you want to know what this white stuff is. Well, I can't really tell you, but all I can say is that it's just another layer to help the resin flow through when it's in the mold. So let's go see that happen. Inside here is a frame ready to be bored. Let me try and talk you through what you're seeing here. This big orange hose here is pushing air into this bucket of resin. This resin is now flowing up through here and it goes through lots of little channels. Now these little lines here is when the resin flows back out, and it starts off under a vacuum. So right here, a vacuum is helping to pull all that resin through, a bit like bleeding a brake. Other things you can see, these blue lines here are keeping the air pressure on those bags on the inside, inflating those bags, adding to the compaction. And then these white lines you can see are all part of the heating elements. So you see these red lines, this bottom section here is all heated. And if you swing over to this one, they've actually got one that's sort of cracked open. We can see what's happening. So these big threaded areas are for inflating the bladders, and you can see all the lines that they've machined to help that resin flow through and make sure it's impregnating all the parts of the carbon fibre. Enrique, our audience would love to know, how are you maintaining your manufacturing tolerances on your bottom bracket headsets and all this? What's the process?
So we try to maintain them about not touching them. Okay. So that's why we try to be as accurate as possible on the inserts we put in the mold. We use steel inserts, tolerated steel inserts, so we don't touch them in order to be as accurate as we can be.
And you make those tolerances accounting for the thermal expansion that must happen inside there. So Enrique, you were telling me off camera that a lot of the times the inaccuracies we see actually comes from the mould being overused and the mould just being taken out and bashed around.
We don't use those molds massively, okay? We don't have such a mass production that we risk to damage them, but always we control them. You know, in Asian factories that they come out of the mold with sort of the right tolerance, but there's always a machining process afterwards. And I think, in my opinion, is that what, let's say, fuck a bit the tolerances, you know, because there's machining afterwards.
Quite often the ovalization we see can actually be from an enthusiastic finishing process as opposed to just taking it out and it being okay.
Yeah, exactly. So this is actually the main triangle of the Race Max 2. In this case, it's the model we launched back in October last year.
Most of this looks like, I mean, the surface finish is almost perfect. You can't even see the lines of that tape that you had on there. It's just flashing.
Yeah, it's flashing and then preparing the surfaces for painting, right? You need to do a sanding to make the surface to be rough for the paint to adhere.
And you say sanding, but you've got a fascinating process of deburring this. I can't wait to show you. Everyone, this is Louis, part of the new generation at this factory. From what I hear, drilling is just the start of what this machine can do.
Yes, exactly. The idea is to have the drilling, deburring and sanding in this robot.
All in one thing. So you're going to basically glue the frame up, put it in here and let a robot do.
Exactly.
And how close are we to that happening?
So the drilling has been done, the sanding actually has been done as well. So it's really the deburring that's going to be very tricky because you can't go too deep, so you really have to be very concerned with it.
Can you see a time when this factory has multiple versions of this machine?
Well, it could be because when we have all the phases in one robot, there will be a lot of machine time, so probably higher than half an hour per frame. So at some point it might become a bottleneck. So when we do everything inside, we might have to get another one.
We're almost there. We have a perfectly smooth front triangle. We have a perfectly smooth and manufactured rear triangle. This last station is putting those two together. So these big solid blocks we haven't seen before, these are actually heating elements. So these red cables come behind here to a little computer controlling the exact temperature to really help that glue cure. Nice. So this is a fascinating room. This is their testing room. You've got 3 test stations you just talked me through. One for stiffness, one for strength, one for fatigue. You've just got this set up here with one of your gravel bikes. Big chunk of weight on here. What are we testing here? What are we looking at?
So in here, this is actually to preset the frame. Then we will add 2 times 20 kilos. Here what we measure is in particular bottom bracket stiffness. Okay. So we apply the load in this angle and then a crank arm, and we measure which is the bottom bracket stiffness of the frame. So it's the feeling the rider will get when pedaling.
So what you've got here, you've got essentially 175 millimeter crank on the pedaling load in this direction, and you've got this brace here which would represent the chain. And you're measuring the deflection
on this direction.
In this direction. And you've got a little DTI here measuring the deflection and stuff. So here's an interesting question for you. Because you do the Race Max in pre-preg and your Italia version, which one is stiffer?
No, the Italia.
Italia?
Yeah. So the Race Max Italia on bottom bracket was about 9% stiffer than the current made in Asia with pre-pregs.
9% stiffer for the same weight?
From the same weight. So stiffness to weight improved, yeah. And the head tube torsion represents the feeling the rider have on a downhill.
Yeah. And is
on a
stiffer
descent.
always better?
No, it is not.
Yeah.
So we have found a sweet spot. Let's say if it's too stiff, going downhill, bumpy road, the frame won't absorb those bumps, so it will take you out of the line. While if it is too flexible, under braking, it might worry a bit and might be scary.
And it's interesting, with your construction method, do you feel like you can fine-tune those characteristics more with your method or with the pre-preg, lots of small pieces layered?
No, I think also our method, apart from the choice of the fiber type, as I say, we can play with the angle 1 degree by 1 degree, and at the end, that's what gives you the feeling and the stiffness result. So we have more choice to play with. I will say that with pre-pregs. With pre-pregs, you have unidirectionals, right?
Yeah.
And then usually you have 0, plus minus 45, plus minus 30 is what they do in Asia.
Yeah.
So we have plenty of choice from 0 to 90, one by one.
So you could have like a 36-degree angle, then a 37-degree angle.
If we consider it's the best angle, we could do that, yeah.
So this machine here, sadly not in use today, but you'll recognise way more electronics. There's a strain gauge down there that you'll recognise from our studio that we use for measuring the spoke tensions, etc. But this one is all about measuring the absolute strength of the product, and they can get some very, very accurate numbers. And then the last part of this equation is measuring the durability of all that stiffness and that strength with some fatigue testing. It's very rare that anything breaks. They've normally got to stop the machine first, but it's a great way of checking that there's nothing going to creep in unexpectedly after a few years worth of use. And this is Luca, and Luca, you do quality control, yeah. Brave man. Can you talk us through what your job here, what do you do at this stage?
Here we check all the tolerance of the frame, all the parts that we put on the frame, so the UDH tolerance, the cable routing, bottom bracket tolerance, and all the mounting of the front derailleur, the storage hole, seat post.
Yeah. Anything where you're going to mount something.
Yeah.
It's like music to my ears. So can you show us what tools you're using to check?
Yeah, I use...
What you're seeing here is probably the most comprehensive quality control stations I have ever seen. Not just using a visual inspection and a few gauges to check. Here they are actually using proper tools to really make sure it's been perfectly deburred and is perfectly accurate. Here we're using 12mm reamers. Here we're using the VAR flat mount tool as well. And when you come to the bottom bracket, you can see here, we're using a go, no-go gauge, but also a tapered tool as well. So you get an idea of what the intolerance might be. You come down to the headset and we are perfectly fitting the bearings in, and he is feeling and looking for any imperfections that are going to make that bearing not sit perfectly flush. When it comes to all the small fittings and fixtures, you forget how many there are on a bike, and there are dozens. Fascinating insight to this. This guy was passionate about getting it right. As I sit here with longer hair than in that video, I reflect on my visit to 3T, and it was a place full of young, educated, enthusiastic people. The whole energy in the room was all about how can we refine that process. And Enrique, who runs that factory floor, was very enthusiastic about taking on new ideas and trying things and seeing if they can make it better. One of the little dreams that he said off camera was, one day I'd like to be able to sell this process to other brands so that other brands can hope to make their bikes back in Europe again. What a great ambition to have. Now, the thing is, you'll be asking in the comments is, does it make for a better product? Here's the thing that Enrique sort of said off camera, and that was the more human error that you can eliminate, the better. So all those individual pieces of carbon fiber, they all require a human to follow precise instructions of laying up something in exactly the right orientation and exactly the right place. And when you see problems, it's normally down to a human error of not following the process. He doesn't have that problem because everything is programmed, everything gets repeated absolutely perfectly. I came into this project thinking that 3T were somewhat of the gravel bike or the Italian version of Time, because they share the same sort of resin transfer moulding methodology. 3T are definitely a hybrid construction method. Yes, we see elements of filament winding. Yes, we see parts that were woven. We see foam cores, we see airbag cores, we see bits of traditional layup as well. Every single part of the bike was sort of optimized. What is the best way of approaching that one little thing? Whereas Time, nearly everything is all woven for different reasons. One last thing before I wind this video up and hand it over to you guys in the comments, and that is pricing. I know that you're desperate to know is, yes, but can you make it as cheap as they can make it in Asia? Well, here's the thing. 3T are going to argue that they already are, because you look at the European brands that are exporting from China, the Pinarellos, the Colnagos, etc., that still have a made in Taiwan, made in China sticker on them. They'll argue that they're already cheaper than those brands. And I totally get it, and so are Time, to be completely fair. Now, can they get as cheap as the factory direct brands, you know, like cutting out all the middlemen and shipping it directly? Possibly was the answer. And that would depend on the European appetite for distribution, because there is still an appetite in Europe to buy from dealers, to buy from bike shops. And that's where a little bit of the money goes, alongside things like shipping, packaging, insurance, bits and pieces like that, which inflate all European bicycles. But there is definitely an ambition and a belief that it can actually happen. It just needs to scale a little bit further. Now, I do hope you enjoyed this video. I cannot wait to read your comments down below. Get stuck in, let me know what you think. See you on the next video.